So chapter 1.3 is distance and midpoints. The first vocabulary word is distance. And the distance between 2 points is the length of the segment with those points as endpoints. And so if I have point A and point B over here, then the distance between those two would be the length. If I have 5 inches, then the distance would be 5 inches, right? The next one here is an irrational number. Irrational number. And so what is an irrational? And I'm sorry, that's 2 R's. IRRA, right? Irrational number is a number that cannot be expressed as a terminating or repeating decimal. What is a terminating decimal? It's like 3.2. It ends at 0.2, right? A repeating decimal is 3.3333333 forever, and so we note that by putting a line over the 3, right? So if we have an irrational number, it's not this type of fraction, it's not that type of fraction. So what are some examples of that? Square root 2 is a non-repeating, never terminating decimal number. So is square root 3. And also, this is one that's very famous. It's pi, right? So 3.14, and it goes on forever. So that's an irrational number. Here we have the midpoint of a segment. So this is midpoint. And what is a midpoint of a segment? It's that point halfway between the endpoints of the segment. So if I'm over here and I have A and I have B and I have M as my midpoint, then that means that AM is congruent with MB, right? Or AM is the same distance as MB. So I could say like 2 inches and 2 inches, right? M is the midpoint between A and B. Last one is a segment bisector. So we say segment bisector is any segment, line, or plane that intersects a segment at its midpoint. So it's kind of hard to draw a plane intersecting a segment at its midpoint, but I can draw a line, right? So here we go. This is M right here, and I'm going to draw 2 congruency marks. And here, so let's say line L is the segment bisector of line segment AB, right? Line L is the segment bisector of segment AB. Okay. So what are the 2 formulas that we're going to be working with today? It's distance and midpoint. All right. So distance, like watch, if I come over here, we got midpoint, like how to calculate the midpoint of a segment, and we also have how to calculate the distance between 2 points. So the first one here is distance between 2 points. How do we calculate it? Well, it depends on whether we're on a number line or whether we're in a 2D coordinate plane, right? So this is 1 dimension, this is 2 dimensions. And so if it's 1 dimension, right, we do the measure of AB is equal to the absolute value of x1 minus x2 or x2 minus x1, right? That's on a number line. And then here on a coordinate plane, what we use is the distance formula. So it's square root x2 minus x1 squared plus y2 minus y1 squared, right? So this is for a coordinate plane. Let's go over a couple of examples. The first one is use this number line to find the measure AB, where A is -4. So this is a typo. This should be -4, and B is 2, right? -4 and 2. So using the formula above, I'm going to say measure of AB is equal to the absolute value of x1, which is -4, minus x2, which is 2, like so. Okay. And so I'm going to say equals -6 by combining those like terms. And how do we deal with the absolute value signs? Well, the absolute value of a number is the positive version of that number. So it's not going to be -6, it's going to be +6. So the measure of AB is +6. All right, and we're done. Over here, this is the distance between 2 points, A and B, and this is in 2 dimensions, right? And how do I know? Because I have an X and a Y. So this first one is going to be x1, and the second one is going to be y1. And then for B, it's going to be x2 followed by y2. right? So this is the first x point, this is the first y point, this is the first x point, second x point, the second y point, and we're going to plug those values into our distance formula. So I'll say distance d is equal to the square root of x2, which is 1, minus x1 is negative, right? So I'm going to have to be careful and say negative 2 in parentheses, squared, plus y2, which is 3, minus y1 is negative, so we got to be careful and put parentheses around that, squared, like so. Right. All right, and so we're going to simplify. So minus and a minus become positive, right? So it's the square root of 1 plus 2 squared plus 1 plus 1, right? Minus and a minus become positive, so it's going to be 3 plus 1 squared. So that's going to simplify to 3 squared plus 4 squared, and then that's going to simplify to square root of 9 plus 16, and that's equal to square root of 25. Now how do we deal with the square root of 25? Well, we do the prime factorization of 25, which is 5 times 5. We have two factors that are the same, so one of them can come out. So the distance between point A to point B is 5. Okay. So yeah, that's how we're going to use this formula to find the distance on a number line, and this formula to find the distance on a coordinate plane.